AMC 12A 2022 problems. We want to solve all 25 problems in this video. Also, we want to find the ideas that are useful in this exam and other exams. And before this exam, exactly the day before this exam, I released a video preparation for AMC 1012. In that video, I've considered 11 useful ideas and general ideas for solving these problems. I will explain for you how those ideas were useful, and you could solve many problems here, like considering cases, Vieta's formula, all those things, quadratic things, and how they were useful in this exam. Okay, so let's start. And if you had any question about the solutions, or want to think, or want, for example, learn something new, you can send message. Feel free to send message to my WhatsApp number in the description and comments. Okay, let's start. Problem number 1. It's over 3. Let's calculate 3 plus 1 over 3. If you use common denominator, 3 times 3, 9, plus 1, 10. 10 over 3. So it will be 3 plus 1 over 3 plus 1 over 10 over 3. And it will be 3 plus 1 over 3 plus, we should consider reciprocal of this, 3 over 10, because 10 over 3 is in the denominator. Now, in next step, I should calculate this part, 3 plus 3 over 10. 3 plus 3 over 10, if we use common denominator 10, it will be 30 plus 3, which is 33 over 10. Now, if I write it, it will be 3 plus 1 over 33 over 10. 1 over this, we consider reciprocal of that. It will be 3 plus 10 over 33. And if we use common denominator, it will be 33. 3 times 33, 99, plus 10, which will be 109 over 33. So, it is our answer, and the answer will be D. AMC 12A problem number 2, 2022. The sum of three numbers is 96. So let's consider first number A, second number B, third number C. Sum of them 96. The first number is 6 times the third number. So first number is A, 6 times third number, and the third number is 40 less than the second number. So third number is 40 less than second number. So okay, I want to calculate, let's see the problem wants what? It says, what is the absolute value of the difference between the first and second number? So, absolute value of A minus B. Now, here in this problem, I want to use replacement. And you have more than one variable, replacement. This problem is easy. It can solve also harder problems. So, I will calculate all of them in terms of C. So, from here, I can say C plus 40 is B, so I can write B in terms of C and A in terms of C. So let's replace. Here, A is 6C plus B is C plus 40 and plus C equal to 96. Left side will be 6C plus C plus C, 8C plus 40 equal to 96. So if you subtract 40 from both sides, 8C will be 56. Now, if we divide both sides by 7, C will be 8. Now that C is C is 7. If we divide both sides by 8, because we have 8C. So, C will be 7, because C is 7. A is 6C, which will be 42, 6 times 7, and B will be 40 plus 7, 47. Now, if we calculate absolute value of A minus B, it will be 42 minus 47, which is negative 5, absolute value of negative 5 equal to 5. So the answer is 5E. AMC 12A 2022 problem number 3. 5 rectangles A, B, C, D, and E are arranged in a square shown below. These rectangles have dimensions 1 by 6, 2 by 4, 5 by 6, 2 by 7, and 2 by 3 respectively. The figure is not drawn to scale. Which of the 5 rectangles is the shaded on in the middle? So here, let me write all the sizes: 1 by 6, 2 by 4, 5 by 6, 2 by 7, and 2 by 3. And we know that all of them are in the square. So the general figure, the greatest figure, is a square. Now, in some problems like this, you should try to find an example that satisfies all these things. We should know this side should be equal this side, and this. Okay, 1 by 6, let's consider it is 1, it is 6. Now, this one is okay. This one, if you want to create the side of a square, for example, 8, if you want to create 7, for example, 6 plus, we don't have 1. If you want to create 9, you need 3. Then 6 by 3, then you need 1 by 8. We don't have 8. So, if you create 2, if you want to create 8, we have 6, 2, we have 1, 7, we have 3, 5. We have many things to create 8. And so, 1 here, let's consider here 7. So, we consider it is 2. It is 2. And this one, 2 by 7 here. 1 by 6. Now this part, let's see what can we say. It is 2, so we call this one 4 because 2 plus 4 is 6. So what we have 2 by 4, so it will be 2. It is 7, so it will be 5. We have 5 by 6, so this one will be 6. It is 4. It should be 2. And what is left? 2 by 3. And we can say it is 1, it is 2, and satisfy all of them. So the answer is 2 by 4 for this one. So the answer is this, which is B. AMC 12A 2022, problem number 4. So before solving this problem, I want to tell you the video I released the day before the exam, I solved a problem in the case, considering special cases and small examples. I've solved an LCM problems, least common multiple. It was exactly like this. I said first consider prime factors one by one. If you saw that video before the exam, you could solve this problem easily. So let's solve the least common multiple, LCM, of a positive integer n and 18 is 180. And the greatest common divisors means GCD, divisor of n and 45 is 15. What is the sum of the digits of n? And n is a positive integer. So here, if I prime factorize, like the problem I've solved before exam, 18 is 9 times 2, which is 2 times 3 squared. 180, 0 is 2, 5, 18 is 2 times 9, so it will be 2 squared times 3 squared times 5. Now, here, GCD of n and 45. 45 is 9 times 5, which is, you can say, 3 squared times 5 equal to 15, which is 3 times 5. Now, if you analyze the first part, here, n can only have 2, 3, or 5, because, for example, if n has 7, in LCM we will see at 7. So, n can only have 2, 3, 5. So, let's consider n is 2x, 3y, 5z. So, if I rewrite these two things again by this n, the first line is LCM of 2x, 3y, 5z, and 2 times 3 squared equal to 2 squared times 3 squared times 5, and GCD of n, which is 2x, 3y, 5z, and 3 squared times 5 equal to 3 times 5 again. Now, in next step, I know in LCM we should consider maximum. So, from this part, I say maximum of, for power of 2, 2x, 1. So, maximum of x and 1 is 2 here. In LCM, we consider maximum of the powers. Maximum of y and 2 for 3. Powers of 3 is 2. And the next one, maximum of z and 2 equal to, let's consider z and 2. Sorry. Here we don't have 5. So z and 0 equal to 1. So from first part, we conclude x equal to, let me move it to the left. So when maximum of x and 1 is 2, obviously x has to be 2. When maximum of y and 2 is 2, you can conclude y is at most 2. When maximum of z and 0 is 1, so obviously z is 1. Now, let's consider the cases of this. GCD of this. In GCD, we consider minimum power. Minimum of, so we know x is what, we know z is what, here we should find y. You can also check x and z, you will see it's satisfied. So minimum of y and 2 equal to 1 because the power here is 1 for powers of 3. So minimum of y and 2 is 1. So y is 1. Now, n will be what? 2x, 3y, 5z. Let's replace. 2x is 2, 3y is 1, 5z is 1. So it will be 4 times 3 times 5. 5 times 3, 15. 4 times 15 will be 60. So n is 60. But the problem wants what? The problem says, what is sum of the digits? So the answer, sum of the digits will be 6 plus 0 equal to 6. Look, the problem says, what is the sum of the digits? So the answer is B. AMC 12A 2022 problem number 5. The taxi cab distance between points x1, y1 and x2, y2 in the coordinate plane is given by absolute value of x1 minus x2 plus absolute value of y1 minus y2. For how many points P with integer coordinates is the taxi cab distance between P and the origin less than or equal 20? Okay, so if we consider the xy coordinates, so less than or equal 20. Now, if we consider exactly what points equal to 20, so let me draw a little larger one. So this part that is 20, the part that is 29, here 20, here negative 20, and this part negative 20. If we draw lines here, this part, this part, this part, this part, we should consider all points that the coordinates are integers. And for example, it is 19 and 1. The next one is 18 and 2. So we consider 1 and 19. Okay, so these points, some of them are 10. For example, like 119. And for example, when 119 is good, negative 1, negative 19 is also good because it will be this point. Let me show negative 119. Also, negative 119 is good. Negative 119 will be this point. And also 1 negative 19 is good. So this number. And sorry, 119. Let me erase. I've meant this. So when we find one number, we can, if both of them are positive, we can consider plus minus that. So 4 times the answer that x and y are not 0. So we can consider x and y or both of them are greater than equal 1. So that's the case that x is 0 or y is 0. So if you want to consider them, we have 1 to 20. They are on x-axis or y-axis. 20 here, 20 here, 20 here, and 20 here, and also origin. So it will be 4 times 20 plus 1, which is 81. Now we should focus on this part. The points here. That how many points are there? So x and y are at least 1, and their sum is less than or equal 20. So x and y are at least 1 and x plus y is at most 20. So this problem has an idea. Let me solve this with 2 solutions. The solution number 1 is for the students that are not professional. And second solution is for students, a trick I use. So at first I say x plus y 20. It will be what? 119, 218, 19, 1. So how many cases are there? 19 cases. If x plus y is 19, then it will be 118 to 18, 1, 18 cases. And we go 19, 18 up to x plus y is 2, Then we have 1, 1, which is 1 case. So the answer for this case is 19 plus 18 plus 2, 1, which is 19 times 20 over 2. 20 over 2 is 10. 10 times 19, 190. So if you replace it here, it will be 190. 4 times 190 equal to 760. 4 times 20, 80 plus 1. So it will be 840. 840 plus 1, 841, which is C. Okay, now let me tell you second solution. Second solution, you save it. Solution number 2. You want to calculate x plus y less than or equal to 20. Xy is at least. So the idea for solving this part is that you say x plus y, the difference, for example, consider the difference is d, equal to 20, and d is at least 0. Now I define d prime equal to d plus 1. So x plus y plus d prime equal to 21, which d prime is at least 1 because d is at least 0. Now, suppose that in these types of problem you have 21 balls, you want to divide it for 3 integers. The first is for x, the next one is for y, the next one for d prime. These types of problem are so much famous. That sum of some variables with coefficients 1 equal an integer. So you say it will be 20 places between them we have, and we should select 2 bars. 20 stars and bars we call it. If you want to learn this idea and other ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. It will be this, which is 190. Exactly this part, this part. But if, for example, instead of x plus y, we had 4 variables, solution number 1 couldn't be useful, and solution number 2 will be useful. So you should learn different ideas that are useful in AMC exam and other exams. Okay, let's go to next problem. Problem number 6. A dataset consists of 6 not distinct positive integers 1, 7, 5, 2, 5, and x. So they are not distinct, we have 2 5s. The average arithmetic mean of the 6 numbers equals a value in the dataset. What is the sum of all positive values of x? So x is positive, and also it says positive integers. So x belongs to positive integers. Now, let's calculate arithmetic mean. It's 1 plus 7 plus 5 plus 2 plus 5 plus x. How many variables are there? How many numbers are there? 1, 2, 3, 4, 5, 6 over 6. Also, the problem says 6. Equal to, it says, the arithmetic mean equals a value in the data set. So, it will be 1 or 7 or 5 or 2. The next one is 5. We said 5, so we don't write it twice. It will result same number. Or x. So if we calculate 1 plus 7 plus 1 plus 7 will be 8 plus 5 13 plus 2 15 plus 5 20. So 20 plus x equal, let's multiply by 6. 6 times 1 or 6 times 7 or 6 times 5 or 6 times 2 or 6x. So let's calculate, simplify. 20 plus x equal to 6, or 6 times 7 42, or 6 times 5 30, or 6 times 2 12, or 6x. Now in next step, if I want to calculate these numbers, so let's write for each of them. 20 plus x equals 6, 20 plus x equals 42, 20 plus x equal to 30, 20 plus x equal to 12, and 20 plus x equal to 6x. So because we know that x is positive integers, so each of the left hand side will be at least 21. So first part is bad, and let me write with green. It is bad. It is also bad because no, this part is bad, 12. So let's check each of them. We take 20 to right hand side, it will be x equal to 42 minus 20, which is 22. The first answer. Next one, x equal to 30 minus 20, which is 10. Second answer. This one, you take x to right hand side, 20 equal to 6x minus x, 5x. So x we divide by 4. X will be 5. It will be divided by 5, sorry. We divide both sides by 5, so x will be 4. Now the answer, it says calculate sum of them. 22 plus 10 plus 4. 22 plus 10, 32 plus 4, 36. So the answer is D. Problem number 7, AMC 12A 2022. A rectangle is partitioned into 5 regions as shown. Each region is to be painted a solid color: red, orange, yellow, blue, or green. So we have how many colors? 1, 2, 3, 4, 5. So that regions that touch are painted different colors. So for example, this and this should have different colors. This and this should have different colors. All these things. And colors can be used more than once. How many different colorings are possible? So look, some types of problems, you should start from what point, and the others, for example, the number of cases will be always same. For example, like what? Here, I start from this rectangle. The order of filling the cells are important. How to fill is important, the order is important, and if you want to learn these types of problems, there are lots of problems like this in DICE, other things. If you want to learn them, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Okay, this cell has 5 cases. For example, without loss of geometry, you consider it is red. And then for this, it cannot be red. It has 4 cases always after filling this. So for example, you consider this yellow. Now, this part cannot be yellow, cannot be red. So it has always 3 cases. It is not important this 5 colors is what, this 4 colors is what. 2 of the colors here will be removed and 3 colors will be left. For example, green. Now, when you reach this part, it cannot be only red and green. It can be yellow, for example, or the other 2 colors. So it has 3 cases, for example, yellow. Now, when you reach this, again, it cannot be these 2 colors that are not equal also. It can be R, Y, or other colors. So it has 3 cases, so the answer is 5. For each of these 5 colors, all these 4 colors are good. For each of these 4 colors, all these 3 colors are good. Times 3 times 3. 3 times 3 times 3 is 27. 5 times 4 is 20. 20 times 27 is 540. So the answer is D. AMC 12A 2022, problem number 8. The infinite product of cube root of 10 times cube root of 10 times cube root of cube root of cube root of 10 and so on is what evaluate to a real number. What is the number? So if I want to calculate, okay, cube root of, know this, let me tell you 2 things. If you have m, it will be a to the power of 1 over m. And if you have a to the power of m to the power of n by power rule, it will be a to the power of mn. So when I want to calculate cube root of 10, I write it as 10 to the power of 1 over 3. When I want to calculate cube root of 10, I say it is cube root of 10. I write it like this. Again, if I apply it, it will be 10 to the power of 1 over 3 to the power of 1 over 3. If I use this, it will be 10 to the power of 1 over 3 squared. We multiply. Again, if you calculate cube root of 10, similarly, it will be 10 to the power of 1 over 3 cubed. So, because we product them, it will be 10 to the power of 1 over 3. Let's call this one, for example, t. T equal to 10 to the power of 1 over 3 times 10 to the power of 1 over 3 squared times 10 to the power of 1 over 3 cubed, and so on. And another power rule is a to the m times a to the n is a to the m plus n. So I can say it will be 10 to the power of 1 over 3 plus 1 over 3 squared plus 1 over 3 cubed, and so on. So for calculating this, I should calculate the power. So let's consider this power. I consider this power as, for example, W. It will be 10 to the power of W. I want to calculate W. For calculating W, it has 2 solutions. One thing, there are 5 important identities, 5 or 6, I can say. They are bases of all other identities. You should memorize them. And if you want to learn them, feel free to send message to my WhatsApp number in the description and comments. I only tell you the identity here is useful. So solution number 1. I say W is this. 3W is what? Is 1 plus 1 over 3. Because you multiply this by 3, the next one by 3, it will be 1 over 3. It will be 1 over 3 squared. And so on. And if you subtract 3W minus W, so this will be cancelled, this will be cancelled, this will be cancelled, so it will be 1. And 2W will be 1, and W will be half. This is solution number 1. Solution number 2, if I want to use it with identity, we have a famous identity that 1 plus R squared plus R cubed, and so on. For the case that R is between 0 and 1, it will be 1 over 1 minus. Now, if I want to apply this identity, I want to calculate 1 over 3 squared, 1 over 3 cubed, and so on. Then I factor from 1 over 3, it will be 1 plus 1 over 3 plus 1 over 3 squared, and so on. So if I want to use this identity, I use it here. In this case, R is 1 over 3, which is between 0 and 1. 1 equal to 1 over 3. It will be 1 over 3 times 1 minus 1 over 3. And it will be 1 over 3 times 1 over 2 over 3. And we cancel, it will be 1 over 2. So W is 1 over 2. And it will be 10 to the power of 1 over 2, or square root of 10. So let's see, the right choice is what? Square root of 10, which is AMC 12A 2022, problem number 9. On Halloween, 31 children walked into the principal's office asking for candy. They can be classified into 3 types. Some always lie, some always tell the truth, and some alternately lie and tell the truth. The alternators arbitrarily choose the first response, either a lie or the truth, but each subsequent statement has the opposite truth value from its predecessor. The principal asked everyone the same 3 questions in this order. Are you a truth teller? The principal gave a piece of candy to each of the 22 children who answered yes. So this 22 is important. Are you an alternator? The principal gave a piece of candy to each of the 15 children who answered yes. And the third question says, are you a liar? The principal gave a piece of candy to each of the 9 children who answered yes. And how many pieces of candy in all did the principal give to the children who always tell the truth? Okay, so we have 3 types of child, and for alternator we have 2 types. So let me consider truth teller, we consider them with T. So we have 3 questions. It is Q1, it is Q2, it is Q3. We want to see which types get candy for each of these questions. T, Q1, Q2, Q3, truth teller, liar, alternator 1, alternator 2. That alternator 1 start with L. So here start is, for example, truth, they tell truth for the first one. Start with lie. Okay, so let's work on truth teller. Q1, the truth tellers always tells the truth. So Q1, they say, let's consider, are you a truth teller? They say yes. Then, are you an alternator? No, because they tell the truth. Are you a liar? No. For liar, first question, are you a truth teller? They say yes. Are you an alternator? They lie and say yes. Are you a liar? They say lie and say no. Now, A1, question number 1. Are you a truth teller? They start with truth. So, they say no. The second step, they should lie. And now they say what? A1. Here, they should lie. Are you an alternator? They say no, because they should lie. They are alternator, they should lie. The third question, they should tell the truth. Are you a liar? They say no, always no. And for A2, it is exactly reverse of that. For all of them will be yes. The first one, they should lie. Are you a truth teller? They should say yes. The second one, are you an alternator? They should say yes. The next one, because they tell truth here. They should lie here. Are you a liar? They say yes. Okay. So let's consider these questions. In the first questions, they get 22 candies, 15 candies, and 9 candies. 22, 15, 9. 22, 15, 9. So if I consider the number of truth teller be T, here yes is T, L, and A2. T plus L plus A2 equal to 22. The next one, L plus A2. L plus A2 is 15. And the last one, A2 is 9. So A2 is 9. So L is 6. So this part is 15. So T is 7 because some of them is 22. The problem says what is number of candies that the who always tell the truth get. So it will be 7. The answer is A. These are analyzing the problem. We can say logic problems working on truth, lie, something like this. If you want to learn completely these solutions, we have some more ideas for solving these types of problems. If you want to learn them, as I said before, feel free to send a message to my WhatsApp number in the description comment. AMC 12A 2022, problem number 10. How many ways are there to split the integers 1 through 14 into 7 pairs such that in each pair the greater number is at least, so 2 times the lesser number L, greater number G, the greater number should be at least 2 times lesser number. Okay. So here, if we consider these numbers, our numbers are 1 to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. By this definition, that here we have, for example, if L equal to 14, then 2 times 14 should be less than or equal to G. So 28 should be less than or equal to G, and it's contradiction. We know G is at most, greater one is at most 14. So lesser number is at most if you divide by 2, 2L less than or equal to 14. So L is at most 7. So lesser number can only be between 1 and 7. So because we have exactly 7 lesser numbers and 7 greater numbers, so all these 7 should be lesser numbers. The only possibility, all these 7 numbers should be greater numbers. So here, let's consider. If we have lesser number 1, greater number, suppose G1. Let's see G1 can be what numbers? G1 can be at least 2. Can be 2 or, because we said greater numbers are from 8 to 14, it can be 8 to 14. If the lesser number is 2, G2, G2 can be from, let me write all of them here, 8, 9, 10, 11, 12, 13, 14. And for next one, it will be 8, 9 again, 10, 11, 12, 13, 14. Now, let's consider if the lesser number is 3, G3. G3 2 times this, again 8, 9 to 14. If it is 4, G4, the greater one can be 8, 9 to 14 because it is 2 times this. So if it is 5, G5 can be from 10, 10, 11, 12, 13, 14. If it is 6, G6, G6 start from 12, 12, 13, 14. Also, you can consider the cases of G1 to G. In AMC 10 problems that I released, I consider the cases of, I said, for example, if G1 is this, L1 can be what numbers? Both of them should reach same answer. 7, G7, G7 can be only be what? 14. Okay, so let's calculate. G7, always start from limited parts. It is one important idea. Also, I said in the video I released before the exam preparation, in counting, I said pay attention to most limited one, only not in this problem, in many problems. G7 has only one case. Here, G6 has 14 will be removed as two cases. So multiply for each of them. This one, two of them has been removed, 1, 2, 3, 4, 5. You multiply by 3. Now, 14 to 8, how many numbers are there? 7. 3 of them has been removed. 7 minus 3 will be 4. The next one, 7 minus 4 will be 3. 7 minus 5 will be 2. And 7 minus 6 will be 1. So if we calculate, 1 to 4 is 4 factorial is 24. 2 times 3, 6. 6 times 4, 24. 24 times 3 times 2. 3 times 2 is 6. 6 times 24 is 144. So the answer is 144. As I said, this problem is also in AMC 10A 2022. In that solution, I saw with different way. Okay, so it's not important to consider what property. I can consider G greater one or lesser ones. You should pay attention to calculate correctly. Okay, so let's jump into the next problem. AMC 2212A, problem number 11. What is the product of all real numbers x such that the distance on the number line between log 6 of x and log 6 of 9, so the distance between them is absolute value of log 6 of 9 minus log 6 of x equal to is twice the distance on the number line between log 6 of 10 and 1. So you can say log b of b is 1. Okay, so I can say 2 absolute value of log 6 of 10 minus log 6 of 6. Now, when you have difference in log problems, you can say log m minus log n. When the bases are equal, it is log m over n. So I can say it is 2 times absolute value of log 10 over 6. 10 over 6, which will be 5 over 3, log 6 of 5 over 3. Now you want to say it is positive or negative. If you consider log graph, it will be this. Before 1, it is positive. After 1, it is negative. For the case, it is x, it is log b of x. And in this case, b is greater than 1. So here also 6 is greater than 1. So 5 over 3 is greater than 1. So it is positive. So it will be 2 log 6 of 5 over 3. Now, next thing. When you have coefficients, a, or let me tell you, m times log b of a equal to m times log a to the power of, sorry. You should take m to the power log b of am. So it will be what? Log 6 of 5 over 3 cube squared. Now here, if we apply the difference in logs, like this part, let me show you, like this part, here it will be log 6 of 9 over x. But because it is absolute value, so let me write. It is log 6 of 9 over x, absolute value of that, equal to log 6 of 5 over 3 squared is 25 over 9. So we have two cases. It is positive or negative. By the graph I told you, case 1, 9 over x is, if it is 1, it will be 0, but right side is not 0. So it is greater than 1 or less than 1. Case 1, greater than 1. So this part will be positive because the graph will be like this. So it will be log 6 of 9 over x equal to log 6 of 25 over 9, because it is a one-to-one function. Or we can say, we can conclude 9 over x equal to 25 over 9. So x equal to 9 squared, 81 over 25. Now, and let's see the problem once. What the problem says, and what is the product? So one answer is this, and you can check 81 over 25 or 9 over x is greater than 1. So one answer is this. Case 2, 9 over x is less than 1. So left side will be negative. So negative log 6 of 9 over x equal to log 6 of 25 over 9. Now, by using this rule, here m is negative 1. So you conclude log 6 of 9 over x to the power of negative 9, which will be x over 9, equal to log 6 of 25 over 9. Because it's one-to-one function, you can say x over 9 equal to 25 over 9. So x is 25, and if you multiply, we found two answers. The problem says find product. If you had question about logarithm or one-to-one or graphs, as I said before, you can feel free to send message to my WhatsApp number in the description and comments. Okay, so product is what? And also, if you pay attention, 9 over x here will be less than 1 because x is 25. So product equal to, and the answer of the problem, 81 over 25 times 25. They will be cancelled, and the answer will be 81, which is E. AMC 12A 2022, problem number 12. Let M be the midpoint of A, B in regular tetrahedron ABCD. What is the cos angle CMD? Okay, as you can see in this figure, for example, it is alpha, and then we want to find cos alpha. Exactly the day before the exam, I released a video. In that video, I said some formulas, around I think 10 formulas from 50 important formulas in geometry. You should know one of them, cosine rule. It's famous. You can see that video preparation. So cos alpha equal to cm squared plus md squared minus cd squared all over 2 times cm times md. Now, all of them, because it is regular tetrahedron, all faces are equilateral triangle. So, if you have equilateral triangle, we want to see the height will be what in terms of A. So, height will be, let me show you. If we have this, it is A root 3 over 2. You should memorize it. But if you don't know, it is what? So because it is equilateral triangle, it is A half. And if I call this h by Pythagorean theorem, h squared plus a over 2 squared equal to a squared. So h squared plus a squared over 4 equal to a squared. If you take it to right hand side, h squared equal to 3a squared over 4. And we conclude h equal to a root 3 over 2. Also, you can, if you know trigonometry, it is 60, which is a root 3 over 2. Now, I consider the length here is a. So, cm is altitude in face ACB. So, cm is a root 3 over 2 squared. md is altitude in ADB. So it will be a root 3 over 2 squared. CD is a minus a squared all over 2 times a root 3 over 2 times a root 3 over 2. So let's calculate this. In the numerator, it will be 3a squared over 4 plus 3a squared over 4 minus a squared all over 2 times this. It will be 3a squared over 2. So if we calculate 3a squared, so let's multiply both numerator and denominator by 4. It will be 3a squared plus 3a squared minus 4a squared all over. We multiply also denominator by 4. It will be 2 times 3a squared, 6a squared. So numerator is 3a squared plus 3a squared, 6a squared minus 4a squared, 2a squared over 4a squared over 6a squared. And we can cancel a. 2 over 6 is 1 over 3. So the answer is B. AMC 12A 2022, problem number 13. Let R be the region in the complex plane consisting of all complex numbers z that can be written as the sum of complex numbers z1 and z2, where z1 lies on the segment with endpoints 3 and 4i, and Z2 has magnitude at most 1. What integer is closest to area R? So let's draw. Here we say 1, 2, 3, 4. This one is 1, 2, 3, 4. So Z1, it says this part lies on the segment with endpoint 3 and 4i. So 3 and 4i, if we show this, it will be 3, 4i, this part. It is the endpoint to this, and Z1 can be any point here. Let's show with the line. Okay. Now, Z2 endpoint is here. It can be anything here, Z1. Z2 has magnitude at most 1. So Z2 is a circle with radius 1. So let's move it. It's with this center. And Z2 can be anything, for example, here. Okay. If Z1, it is Z2. Z2 can be all this circle. If Z1 0. If you, for example, and then it wants what? What integer is closest to the area of R. So if we draw this circle, if I consider Z1 moves here. So this circle moves here, 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 all these things. And it ends to this point. So we can say all areas between them, we have them. It depends that Z1 is what? So we have all the area from this part, all of them to this. So if I want to draw it, it will be two circles. Let's copy. Okay, it will be this figure. Its center, for example, it is 0, 01. It is 02. 01, 02. And the distance between them, 01, 02, we can say, because it is 3, it is 4 by Pythagorean theorem, 01, 02 squared is 3 squared plus 4 squared, which is 25. So 01, 02 is 5. Now here, 01, 02 is 5, and let me write it here. Why it is equal to 01, 02? Because 01 is perpendicular to this common tangent. And then the radius is what? Radius of this circle. It says 1. So it is 1. It is 1. It is 1. It is 1. So if you want to find the area, it includes a rectangle here, 5 times 2, and plus 2 semicircles, which will be a circle. Pi times 1 squared, which will be 10 plus pi. And it will be 13.14. It is closest to what number? A, which is 13. Okay, if you have question about complex numbers or want to learn other ideas, as I said before, you can send message to my WhatsApp number in the description and comments. AMC 12/8/2022, problem number 14. What is the value of log 5 cubed plus log 20 cubed plus log 8 times log 0.25, where all logarithms have base 10? Okay, in logarithm problems, there are around 10-15 rules if you want to. They are useful in all exams. If you want to learn them, please, as I said before, feel free to send message my WhatsApp number in the description and comments. Okay, so we have a famous identity that a cubed plus b cubed equal to a plus b times a squared minus ab plus b squared. You should memorize. Also, we have for n is odd, and also for minus for all integers n we have. I said there are some identities. You can send message to ask them. So let's consider log 5 cubed. So log 5 cubed plus log 20 cubed. The first part, I want to calculate this. It will be log 5 plus log 20 times log 5 squared minus log 5 times log 20 plus log 20 squared. Okay, so we have one important rule is log A plus log B equal to log AB. So here we can say it is log 5 times 20, 100. And we know the base is 10. And log b to the power of m, log b of b to the power of m is m. So we conclude it is 2. So times log 5 squared. Now look here, because the base is 10, when we have numbers, I release in my other solutions this idea, not in AMC preparation. In my other ideas, that when you are working with numbers, try to consider a variable. For example, like what? I say x equal to log 2. We know it is log 10 of 2. If I want to find log 5, again by another rule in logarithm, log a minus log b equal to log a over b. The bases are equal. Now, if I want to find log 5, if I say log 5, it will be, it is 10, it is log 10 of 10 over 2, which is log 10 of 10 minus log 10 of 2. Log 10 of 10 is 1, it will be 1 minus x. So log 5 is 1 minus x, log 2 is x. Now, here, log 5 will be 1 minus x squared minus 1 minus x, and log 20 is what? Log 20 is log 4 by this rule. Log 4 plus log 5. So let's calculate log 20 in terms of x. Log 20 is log 4 times 5, which is log 4 plus log 5. Log 4 is what? Is on. Another power rule, if you have m log a, it will be log a to the power of m. So here I say it is log 2 squared, which is 2 log 2. And log 5 we say is 1 minus x. Log 2 is x, so it is 2x plus 1 minus x, which will be 1 plus x. Okay, so log 20 is 1 plus x plus 1 plus x squared. And it is log 100. 100 is 10 squared is 2. 2 times 1 minus x squared minus 1 minus x times 1 plus x is 1 minus x squared plus 1 plus x squared. And if you calculate, it will be 2, 1 minus 2x plus x squared minus 1 plus x squared plus 1 plus 2x plus x squared. So if we cancel 2x, negative 2x, and 1, negative 1 also will be cancelled. Okay, 1 and negative 1 will be cancelled. This will be cancelled. It will be 2 times x squared, 3x squared plus 1. Okay. Now let's calculate. It was first part, this part. Let's focus on log 8 times log 0.25. Okay, log 8 is log 2 cubed. Log 0.25 is 1 over 4. So the first one is 3 log 2. The next one, because it is 2 to the power of negative 2, will be negative 2 log 2. And it will be 3 log 2, it is x, negative 2x. It will be negative 6x squared. Okay, so we have this part, this part. Some of them will be what? 2 times 3x squared plus 1 minus 6x squared. It will be 6x squared plus 2 minus 6x squared. They will be cancelled. And the answer will be 2. Okay, so the answer is C. AMC 12A 2022, problem number 15. The roots of the polynomial 10x cubed minus 39x squared plus 29x minus 6 are the height, length, and width of a rectangular box. Right rectangular prism. A new rectangular box is formed by lengthening each edge of the original box by 2 units. What is the volume of the new box? Okay. So we have a cube that For example, like this. That it says we're lengthening each edge of the original box by 2. So if we consider the roots, I release a video. In that video, I explain Vieta's formula. It is so much useful in this problem, exactly the day before the exam. Also for other exam, I will release videos for preparation. Now, it says, for example, it is R1 plus 2, R2 plus 2, R3 plus 2. And the volume is what? The answer. It's R1 plus 2, R2 plus 2, R3 plus 2, which R1, R2, R3 are the roots of this polynomial, the problem says. So if we calculate this, it will be R1, R2, R3 plus 2 times R1, R2 plus R1, R3 plus R2, R3 plus 4 times R1 plus R2 plus R3 plus 8. And you can use Vieta's formula I told you, or here we can calculate the coefficient of x squared on left hand side is 39. We consider 10 here for coefficient of x cubed to be equal. Coefficient of x squared 39 on left hand side, on right hand side will be 10 times negative R1 minus R2 minus R3. So R1 plus R2 plus R3 will be 39 over 10. Now let's consider coefficient of x. On left hand side 29, on right hand side it will be 10 R1 R2 plus R1 R3 plus R2 R3, which will be 29 over 10. So this part will be 29 over 10. Now coefficient of constant term, left side is negative 6, right side is 10 times negative R1 R2 R3. So it will be negative 6 over negative 10, which will be 6 over 10, 3 over 5. Okay, so if we calculate 3 over 5 plus these 2, this 10 will be cancelled, 5, 29 over 5, the next one. 2 here, 5 here, 2 times 39 is 78 over 5 plus 8. So 3 plus 29, 32, 32 plus 78 is 110 over 5 plus 8. It's 22 plus 8, which is 30. So the answer of this problem is D. Okay, so it was degree 3. For degree N, we have Vieta's formula and also how to work with roots. If you want to learn these tricks, these ways, these ideas, as I said before, feel free to send message to my WhatsApp number in the description comments. AMC 12A 2022, problem number 16. A triangular number is a positive integer that can be expressed in the form Tn equal to 1 plus 2 plus 3 to n. The formula here is n times n plus 1 over 2. By Gauss idea, you can solve this. For some positive integer n, the 3 smallest triangular numbers that are also perfect square. T1, 1, T8, 8 times 9 over 2, 36 is 6 squared, T49 is this. What is the sum of the digits of the 4th smallest triangular number that is also a perfect square? Okay, so let's analyze. Tn is n times n plus 1 over 2 equal to a perfect square, x squared. So n times n plus 1 is 2 times perfect square. So look, when product of two numbers, like n plus 1, equal to a perfect square, or p times perfect square, perfect number times x squared, a prime number, then we have two cases. So let's consider first GCD of n plus 1. The GCD is 1. Why? Because if we consider GCD is D divides n, D divides n plus 1, D divides the difference, and GCD always has to be positive, so D is 1. There are co-prime numbers. When there are relatively prime numbers, the product is 2 times perfect square. One of them is 2 times. Also, it is correct for 3, 5 other primes times x squared. So, case 1, n is y squared, n plus 1 is 2w squared. One case is this. Case 2, n is y, for example, n is 2y squared, and n plus 1 is w squared. We have these two cases, and we want to find the minimum one. So, in this case, n has to be y squared, in this case, n has to be w squared minus 1. And in both cases, you can see that we have another condition. So let's consider the cases that we can consider. It says the third one is 49. So we should start after 49. So the numbers we should check. 49 is 7 squared. 7 squared minus 1 you don't need to check, but 8 squared. 64. 64 minus 1, 63. The numbers that we should check. 64, 63. The next one is 9 squared, 81, 80, 81, 10 squared, 99, 100. Let's check some of them to see how we can find. When n is this part, something squared minus 1, then n should be 2 times perfect square. Okay? But n is not 2 times perfect square, so it is bad. When n is 64, it is this case. n plus 1 should be 2 times, so this is bad. So we consider that for 8 squared, even squared, it's not good. Because even squared minus 1 is odd, so we don't need to check 10 squared. We only need to check odd numbers squared. So for 80, n is 80, so it is this. So n should be 2 times perfect square. It is 2 times 40, which is not perfect square. For 81, n plus 1 should be a perfect square. So n plus 1 is 82, should be 2 times perfect square. It's 2 times 41, it is not perfect square. So the next n's we should check. 11 squared, 120, 121. So n is 120, is w squared minus 1, 11 squared minus 1. N should be also 2y squared. It's 2 times 60, which is not that. In this case, 121. And it's something square, n plus 1, which is 122, should be 2 times perfect square, which is not. Now, it is 120, 11 squared. 13 squared, 168, 169. If it is 168, so n should be 2 times perfect square, which is 2 times 84. It's not perfect square. 169 like this, n plus 1. 170 should be 2 times perfect square, which is 2 times 85. No. It was 13 squared. 15 squared, if you check, which will be 224, 225. 224 is 2112. It's not good, not perfect square. 226 also. Here it's 2113. It's not perfect square. It was 15. 17 squared is 288, 289. And if you check, it will be 2144. And it's perfect square. It's 2 times 12 squared. Okay. So n is 288. And the problem was what? It says fourth smallest triangle of form. So n is 288. But we want to find T288. By the formula, it is n times n plus 1 over 2. 288 times 289 over 2, which is 144 times 289. And you should calculate. If you multiply this number, it will be 41616. And it says what is sum of the digits. So 4 plus 1 plus 6 plus 1 plus 6. 4 plus 1, 5 plus 6, 11, 12, 18. So the answer is D. This idea that I told you, when the product of two numbers, you should consider GCD. Sometimes we have GCD. Also, it has other rules. Also, it is useful in BMO, British Mathematical Olympiad, and other exams. So, for knowing these ideas, you can send message to my WhatsApp number in the description and comment. AMC 12A 2022 problem number 17. It says, suppose as A is a real number such that the equation A times sine x plus sine 2x equal to sine 3x has more than one solution in the interval 0, pi, open 0, and open pi. The set of all such A can be written in the form open P, open Q, union open Q, open R, where P, Q, and R are real numbers with P less than Q less than R. What is P plus Q plus R? Okay, so let's focus first on our main equation. A times sine x plus sine 2x equal to sine 3x. We have two important formulas. You should memorize them. So much basic. Sine alpha plus beta equal to sine alpha cos beta plus cos alpha sine beta. Another formula that is important, cos sum of two angles, equal to cos alpha cos beta minus sine alpha sine beta. Now, we can say sine is this, cos is this. If we want to find sine 2x here, if we call it 1, we call it 2. Sine 2x, if we use 1 and alpha equal to beta equal to x, we can say it is equal to sine x cos x plus cos x sine x, which will be 2 sine x cos x. If we want to find sine 3x, if we apply again 1 and alpha equal to x and beta equal to 2x, it will be sine x cos 2x plus cos x sine 2x. And if we use here again this part, let me call this one star, you can say sine 2x is 2 sine x cos x. So this part will be 2 sine x cos x. So let's replace a times sine x. Sine 2x is 2 sine x cos x equal to sine 3x. It will be sine x cos 2x and plus here it will be 2 sine x cos x squared. 2 sine x cos x squared. Now we divide both sides by sine x. And sine x is not 0 because if you consider unit circle, let me show this. From this part to this part, sine is the vertical line. It's not 0. Sine of 0 and sine of pi is 0. So we can divide both sides by sine x. It will be a times 1 plus 2 cos x equal to cos 2x plus, here we have 2 sine x. Let me correct it. It is this part, 2 sine x cos x squared. So plus 2 cos x squared. Now, by this formula 3 by 2, I can say cos squared cos 2x, if we apply 2 and alpha equal to beta equal to x, it will be cos squared x minus sine squared x. Also, I know and we know it's so much basic and famous, sine squared, it is by Pythagorean theorem. Sine squared x plus cos squared x is 1. So we can say it is cos squared x minus 1 minus cos squared x, which will be 2 cos squared x minus 1. So if I replace it here, let me call it double star. By double star, it will be 2 cos squared x minus 1 plus 2 cos squared x. So we can conclude a times 1 plus 2 cos 2x equal to 2 cos 2x plus 2 cos 2x is 4 cos 2x minus 1. And we can factorize this. It will be 2 cos 2x minus 1, 2 cos 2x plus 1. Now, if we divide both sides by 1 plus cos 2x, but we should consider the case. Case 1, if 1 plus 2 cos 2x equal to 0. This is this case. It is 1 plus 2 cos x, not cos 2x. So, if 1 plus 2 cos x equal to 0, then we can't do, it is 0, the left side is 0, the right side is also 0, so cos x equal to negative 1 over 2, and x will be, because x is between 0 pi, you can say it's 120 degrees. Because 60 degrees is 1 over 2, 120 degrees. It's 120 degrees. Or, if you want to say it in radian, it will be 2 pi over 3. This is case 1, that this equation will be satisfied. Case 2. Suppose 1 plus 2 cos x is not 0. It means that x is not equal to 2 pi over 3. So, we can conclude a equal to what? We can divide, let's call this one, for example, 3, this equation. We consider 3 and divide both sides by 1 plus 2 cos x because it is not 0. So a equal to, let me correct this part, is 2 cos x plus 1, 2 cos x minus 1. It will be 2 cos x minus 1. And we know x is between 0, pi minus, except x 2 pi over 3. So let's see a can be what numbers. If we consider cos pi, cos x, and x from 0 to pi, if we consider also unit circle helps. Cos is horizontal function, cos x. So when you start from 0, it will be 1. When you reach pi over 2, it will be 0. It is pi over 2. When you go to pi, here, cos will be negative 1. So it will be something like this. And this part will be negative 1. Now, when you have 2 cos x minus 1, 2 cos x minus 1, if we consider the diagram, this 1 will be what? 2 times 1, 2 minus 1, 1. It starts from 1. And this 0 will be 2 times 0 minus 1 will be negative 1. That means it will be something like this. Pi over 2 will be negative 1. And then for pi, that is negative 1, 2 times negative 1 minus 1, negative 3. So if we continue, negative 3 will be something like here. Pi, and it will be here. Okay. So it says a can be what numbers? A equal to this. But we know x is not 2 pi over 3. We should find that 2 pi over 3 is some angle here. We know that in 2 pi over 3, cos x is negative 1 over 2. So 2 times negative 1 over 2 minus 1 is negative 1. Minus 1 minus 2. So for minus 2, we know it's not possible to reach for a. Because it says x should have 2 answers at least. We know that if it is 0, if x is 0, it is correct for all a's. So because it says we should have at least 2x for satisfying a, 1x for all of them is 2 pi over 3. X is 2 pi over 3, it satisfies this equation. Another thing is also you should find another x. So because we want another x, x should be equal to this part. And because we want to find another answer, x shouldn't be 2 pi over 3. So it means that 2 cos x minus 1 shouldn't be negative 2. So because it says a, the answers for a will be PQ union QR. It will be P is negative 3, from negative 3 to negative 2, it's possible union. Negative 2 to 1. And P will be this, Q will be this, Q will be this, R will be this. Now, the problem says P plus Q plus R is what? It will be negative 3 minus 2 plus 1 will be negative 5 plus 1, negative 4. And the answer will be A. So let's review the solution. For all A, it says what? We want more than one solution in the interval 0 pi. So x equal to 2 pi over 3 is one answer for all A because left hand side and right side will be 0. We've calculated. And we want to find another x that is the answer. So because we want another x that satisfies this equation, a is 2x minus 1. if x is not 2 pi over 3. And we can see if a equal to negative 2, it's not possible because again x is 2 pi over 3 and we want more than 1x. So for all other cases from 0 to pi except 2 pi over 3, we have answer x. So for a, because a equal to 2x minus 1, it will be from negative 3 to negative 2 and from negative 2 to 1, and we solve this problem. If you want to learn important ideas in trigonometry and how to solve, drawing graph is so much useful. It's so much useful, especially in AME. If you want to prepare for AME and other exams, feel free to send message to my WhatsApp number in the description comments. AMC 12A 2022, problem number 18. Let TK be the transformation of the coordinate plane that first rotates the plane k degrees counterclockwise around the origin and then reflects the plane across the y-axis. What's the least positive integer and such that performing the sequence of transformations t1, t2, t3, t and returns the points 1, 0 back to itself. For solving this problem, I use complex numbers. We have two actions here, and we should do it this after the first step. Second step, the first step is this part. Rotate from here counterclockwise k degree. So it will be this one, you change it to this one. So, for example, if it is z, we can call it, if the length is r, it will be rei theta. And when you rotate k degrees counterclockwise, it will be rei theta plus k degree. And the other one is reflect the plane across the y-axis. So, in this case, for example, you have this, you have this. So, if it is rei theta, if you reflect across the y-axis, it will be this angle is theta, this angle also is theta. By congruent triangles, you can easily prove. So this angle is 180 minus theta. So it will be rei 180 minus theta. So if you want to consider, and it is always correct, by t1, it says consider 1, 0. 1, 0 is this point. And it will be ei times 0. So, because r won't change and we want to consider after how many steps we will reach again this point, we don't consider r, we only consider the angle. Here we have 0 degree. In t1, it is 1 degree. 1 degree. Then you consider the sums should be 180. 180 minus theta, which will be 179. So the degree after applying transformation number 1 will be this. Then it is plus 1 and 180. The next one, plus 2, 181. And then this plus this is 180. It will be negative 1. Negative 1 is 359. Both of them are same. Because 360 degrees equivalent to 0. It is 2, 2. We consider plus 3 will be 2. What plus this is 180. So it is T3. T4 plus 4 is 182. And then this plus what is 180 minus 2. It is T4. The next one, plus 5 is 3. Plus what is 180? It will be plus 177. It is T5. Now we should see what's the minimum number of n that Tn between them will reach 0. Okay, so T5, we consider plus 6, which will be 183, negative 3. It will be T6. So let's consider something. I have 179, negative 1, 178, negative 2, 177 after this, negative 3. So, if we consider these numbers, we can see 179, 178, 177. After 180 steps, around 180 steps, it will reach to 0. But negative 1, negative 2, you should go to negative 360. So, this part is better. So it is for T1, it is for T3, it is for T5. Also, you can prove that in the middle of them, you can't reach 0. Okay, so because you go 2 degrees less than 180 before 2 degrees more than 180. But we want to consider after complete, for example, T1, T2, T3. So we want to go and see for T what we will reach 0. It is T what. So for 1, it is 179. For 3, it will be 178. For 5, the distance between 135 or 2, but the distance 179 is, so you should consider the distance divided by 2. So 179, look, minus 3 minus 1 over 2 will be 178. For example, 177 will be 179 minus 5 minus 1 over 2. The distance 5 minus 1 over 2, it will be 177. So 1, if we consider it is n, 179 minus n minus 1 over 2 will be 0. So if you multiply by 2, it will be 358 minus n plus 1 equal to 0. So n equal to 359. So the first number that we will reach is 359. AMC 12A 2022, problem number 19. Suppose that 13 cards numbered 1 to 13 are arranged in a row. The task is to pick them up in numerically increasing order, work repeatedly from left to right in the example below. The cards 1, 2, 3. Let me explain. It's a little hard to understand this problem. It says, for example, we take 1 in first step. Also, we can take 2 because it is on the right of 1 increasing order. 2, we can take 3, but 4 is on left of 3. So in first pass, we only take 1, 2, 3. In second pass, we take 4, we take 5, 6 is on the left, so we can't do that. In third pass, we take 6, again 7 is on the left. So in fourth pass, we take 7, we take 8, we take 9, we take 10, but 11 again is on the left. So in fifth pass, 11, 12, 13, exactly like the things here, the problem explained from this part to this part. Now, it says, for how many of the 13 factorial possible orderings of the cards will the 13 cards be picked up in exactly 2 passes? Okay, when we have 2 passes, in pass number 1, for example, you take 1, 2, 3 to A. In pass number 2, you select A plus 1, A plus 2, 2, 13. So it means what? 1 should be on left of 2. I write with this. I draw the diagram. 2 before 3, 3 before 4, 4 before A, but A is not before A plus 1 because A plus 1 is second pass. So A is after A plus 1, but again, after A plus 1, we have A plus 2, A plus 3 to 30. So look, this diagram is not hard. For example, there is a famous formula, idea, I can say. For example, it says it is before this, it is before this, it is before this, then this one before this one before this. There is an idea. The idea is in first step, if we have 2 parts, try to solve part by part, and consider most limited cases. This one is so much easy in these types of problems. If you want to learn generally how to solve these diagrams, feel free to send message to my WhatsApp number in the description and comments. Okay, so if I want to solve this, let me copy this part. Okay, so I say we don't consider this, and then we subtract the case that let's do something. Let's minimize it a little greater. So I say I calculate this minus the cases that this is on the opposite direction. If we calculate, the problem will be solved. The first part is what? 1 before 2 before A. So you say 13 choose A, you select A elements, A places in 1 to 13, because 1, 2 to 13. these A elements should be in increasing order, and the rest of the elements should be also in increasing order. Minus 1 to 13 is what? Is 1, because 1 before 2 before A plus 1. It should be 1 to the only permutation that satisfies this. Okay, but A should be from what? A can be from 1 to 12, because if A is 13, we don't have past 2. So it will be 13 choose A minus 1. Now, A can be from what numbers? A can be from 1 to 12. So if A is 1, it's 13 choose 1 minus 1. Plus 13 choose 2 minus 1. Plus 13 choose 12 minus 1. Now we want to calculate this. For calculating this, I say it is, the first part is 13 choose 1 plus 13 choose 2 plus to 13 choose 12. How many negative ones are there? Minus 12. So here in first part, I add 13 choose 0, 13 choose 1, 13 choose 2, plus 13 choose 12, plus 13 choose 13, but we didn't have 13 choose 0 and 13 choose 13, so I subtract to cancel them, minus 12. Now, this is a famous identity. As I said, there are some famous identities. You should memorize them. It is all subsets of 13 elements. It will be 2 to the 13. If you want to learn all other identities, hockey stick identities, triangular form of identities, feel free to send message to my WhatsApp number in the description and comments to memorize the identities. Minus 1, minus 1, minus 12. 2 to the 13 is 8, 1, 9, 2. You should memorize 2 powers of 2 up to 2 to the 16. Minus 14. It will be 8, 1, 78. So we found the answer of this problem. 8, 1, 78. The answer is D. AMC 12A 2022, problem number 20. Isosceles trapezoid ABCD has parallel sides ADBC, which BC is less than AD, and AB equal to CD. There is a point P in the plane such that PA is 1, PB is 2, PC 3, PD 4. So if you want to find place of PD, if you draw, for example, a perpendicular bisector, because PA is less than PB, so P should be below this line. Also, if you consider this one, because PD is greater than PC, it should be on top of this line. So if you want to find this, it will be some point, for example, like this. And it will be this, it will be this. Let's connect. Approximately, it will be here. So I consider this is P. PA is 1, PB is 2, PC is 3, PD is 4. What is BC over 8? Okay. Now, when you have these things, 1, 2, 3, 4, one important thing is to use adjacent Pythagorean theorem. What is adjacent Pythagorean theorem? It is so much useful. I saw this in many problems of AMC, also in problems of AME. It means what? When we have this, A, for example, BC, and it is H, it is X, it is Y, it is B, it is C. So H, the Pythagorean theorem in first part is C squared is H squared plus X squared. And right triangle is HB squared equal to 8 squared plus Y squared. So if you subtract C squared minus B squared equal to X squared minus Y squared, it is so much famous. Also, we can prove Carnot theorem with this. So C squared minus B squared equal to X squared minus Y squared. And I want to apply it here. So for applying this, I draw this altitude. This one, this one. So suppose it is, for example, W, it is T. Now, one important thing in isosceles triangle is to draw the heights. So if you draw the altitudes, it is always R equal because of congruent triangles. In trapezoid, it's useful, especially isosceles trapezoid, because both of them will be R. So because it is W, this part will be W plus R. This part will be T plus R. And if you use adjacent, here it was deleted. So let me continue this part. It was this. Okay, here. If you consider adjacent Pythagorean theorem, we can call this adjacent not to forget, but the name is not famous. Use double Pythagorean theorem. C squared minus b squared equal x squared minus y squared. Here, 4 squared minus 1 squared will be what? T plus r squared minus w plus r squared. And 3 squared minus 2 squared again is t squared minus w squared. Now, in first part, 4 squared 16 minus 115 will be t squared plus r squared plus 2tr minus w squared plus r squared plus 2wr. R squared will be cancelled, and we can conclude 15 equal to t squared plus 2tr minus w squared minus 2wr. T squared minus w squared, here we had, it is 9 minus 4, which is 5. So it will be 5 plus 2tr minus 2wr. We subtract 5 from both sides, it will be 10 equal to 2r times t minus w. So if we divide both sides by 2, 5 will be r times t minus w. Now, we have this relationship. Now, let's see the problem once more. The problem says BC over AD. BC is W plus D, AD is W plus R, so BC over AD is T plus W over TW plus R plus T plus R, which will be T plus W plus 2R. So reciprocal of that is easier to calculate. So let's calculate first AD over BC is T plus W plus 2R over T plus W. T plus W over T plus W is 1 plus 2R T plus W. R is what here? R is 5 over T minus W if you divide by T minus W. So it will be 1 plus 2. R is 5 over T minus W, 1 over T plus W. If we multiply, it will be 1 plus 10 T squared minus W squared. T squared minus W squared is 5. So it will be 1 plus 10 over 5. 10 over 5 is 2. 1 plus 2, 3. So the answer of this problem is 3. 3 was reciprocal of that. So AD over BC 3, BC over AD is 1 over 3. Pay attention not to have careless mistake. Unfortunately, we don't have 3 here. Okay, so the answer is B. If you want to learn something like adjacent Pythagorean theorem, some ideas in geometry, 40-50 important formulas and ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. AMC 12A 2022, problem number 21. Let P of x equal to x to the power of 2022 plus x to the power of 1011 plus 1. Which of the following polynomials is a factor of P of x? Okay, so let me tell you. For example, if you have a polynomial like what? For example, x squared plus x minus 2. It is a polynomial that if you replace x with 1, you will see, okay, it is 0, so it is a factor of x minus. And you can say it is x minus 1 times x squared minus x plus 2. It will be this. So if x minus 1 is a factor, for example, consider it is P of x. Then if you replace x minus 1, you say x minus 1, 0, and x replaced with 1 and replace here, it will be 0. P of 1 will be 0. Now, let me tell you another thing. If, for example, P of x, you divide it, for example, is multiple of this. It will be x squared minus x plus 1. This P of x was only, let me tell, Q of x, not to make mistake with this. Q of x, Q. So, suppose P of 1 equal to x squared minus x plus 1 times A of x if it is multiple. So, if I consider x squared minus x plus 1 equal to 0, for example, a root of this, or we replace x squared with x minus 1, right side will be 0, left side also should be 0. So if in p of x I replace x squared with x minus 1 or use a root here, p of x should be 0. It is so much useful idea. You know this is a special case. I think most of you know this idea, but this one is general of this one. So if you want to learn generalization of things in algebra, polynomials, functions, and inequalities, as I said before, feel free to send message. My WhatsApp number in the description comments. Okay, so look, x squared minus x plus 1 has this form, x squared plus x plus 1 this form, x4 plus 1, x6 minus this. So let me show you. It is x cubed squared minus x cubed plus 1. So this one has the form of this one. This one has what form? X cubed squared plus x cubed plus 1. This one has the form of this one. Okay, so the easiest one is to check x4 equal to negative 1. Let me show you how you can prove. So choice C, x4 plus 1. You consider it is 0, so x4 is negative 1. P of x is what? Is x to the 20, 22 plus x to the 10, 11 plus 1. Now you can say it is x to the power of 20, which is multiple of 4 times x squared. Let me write like this, times x squared, plus the next one is x to the power of 108 times x cubed plus 1. So it will be x to the 4, the first one, times 505 x squared plus x to the 4, 2 times 4, 20, 5 times 4, 20, 2 times 4, 8, x cubed plus 1. And then if you replace x4 with negative 1, here it will be negative 1 to the power of 505, which is negative 1. So it will be negative x squared. It will be plus x cubed plus 1. So it will be x cubed minus x squared plus 1. We want to check, is it 0 or not? So if it is 0, then the problem will be solved. We want to see, can we reach contradiction or not we reach contradiction. So if we multiply both sides by x, we know x is not 0 because x to the 4 is negative 1. So x to the 4 minus x cubed plus x equal to 0. X to the 4 is negative 1. So negative 1 minus x cubed plus x equal to 0. Also here, we know that x cubed minus x squared plus 1 equal to 0. So if we add these two terms, x cubed negative 1, 1 will be cancelled. So x minus x squared is 0. So we know that x is not 0 because x to the 4 is negative 1. So 1 minus x is 0. So x is 1. But we know if x is 1, x to the 4 is not negative 1. So here we've reached contradiction for part C. Now let me show you part A, x squared minus x plus 1. X squared minus x plus 1 equal to 0. So x squared equal to x minus 1. Now, if we calculate x cubed is x times x squared, which is x times x minus 1, which is x squared minus x. Again, I replace x squared with x minus 1, x minus 1 minus x, which will be negative 1. Now, because x cubed is negative 1, p of x is x to the 2022. So let's see. P of x is x to the 2022 plus x to the 1011 plus 1. So it will be x cubed to the power of what? To the power of 6, 22, 7, 12, 4 plus here x cubed to the power of 10, 11 is 3, 20, 11, 3, 21, 7 plus 1. Because x cubed is negative 1 here, so negative 1 to the power of even is 1, negative 1 to the power of what is negative 1 plus 1, so it is 1, it is not 0. So A, we've rejected A and we've rejected C, so let's check B. B is x squared plus x plus 1. So it is this x squared, so you calculate x squared equal to negative x minus 1. Now, if we want to calculate x cubed, it will be x times x squared. Instead of x squared, we write negative x minus 1, will be negative x squared minus x. x squared, negative x squared will be x plus 1 by using this. Minus x will be 1. Now, p of x will be x to the 2022 plus x to the 1011 plus 1, we said is x cubed times 6, 7, 4 plus x cubed times 3, 3, 7 plus 1. X cubed is 1, so it will be 1 plus 1 plus 1, 3. So it is not 0. So B also will be rejected. D, x to the 6 minus x cubed plus 1 is 0. So it is similar to exactly A. In A, we proved x cubed is negative 1. Here, because instead of x we have x cubed, we should prove x9 equal to what? Equal to negative 1. So, in D, x6 minus x cubed plus 1. So we conclude x to the 9 equal to negative 1. Now, if you want to calculate px, x 2022 plus x 1011 plus 1. You should subtract 2 is mod 9 is 6. So you should say x6 times x to the 2016 plus this one, you say x cubed times x to the 108 plus 1. It will be x6 times x9 to the power of 2 times 9, 18, 21, 2 times 9, 18, 36, 4 times 19, x cubed times x to the 9 times 1, 10, 1, 18, 12, plus 1. So, x to the 9 is negative 1. Both of them will be 1. So, it will be x6 plus x3 plus 1. We know x to the 6 minus x cubed plus 1 is 0. So, if it is multiple, it should be 0. And x to the 6 minus x cubed plus 1 also should be 0. So, if you subtract, then 2x cubed will be 0. So x cubed will be 0. So the only possible case is x should be 0. But if x is 0, this one is not correct. So D has been rejected. So we understand that the answer is E. But let me solve E for you to see an example that it satisfies. E similar to B. In B, we said x cubed is 1. So here x to the 9 is 1. So x6 plus x cubed plus 1. x6 plus x cubed plus 1 equal to 0. So it is similar to B, only instead of x, we have x cubed. Here we said x cubed is 1, so here x to the 9 will be 1. And if we calculate p of x, like previous parts, p of x equal to what? Equal to x to the 2022 plus x to the 1011 plus 1. Again, we want to use x to the 9. We say x to the 6x 2016. We write it again like this. x2 to 4. We use this part. Plus x cubed times x9 112 plus 1. Because x9 is 1, it will be x6 plus x cubed plus 1. And we know from assumption it is 0. And it is 0, it satisfies. So the answer is E. Okay, this idea also was useful in previous years. So if you want to participate in an exam like AMC, AME, USAMO, BMO for British, IMO, if you solve past papers and find the general ideas or generalize the idea, in next years also you will see problems with same idea, not repeated problems. The ideas will be repeated. Okay, so if you want to learn these famous ideas, general ideas, feel free to send message to my WhatsApp number in the description and comments. AMC 12A 2022, problem number 22. Let C be a real number and let Z1, Z2 be the two complex numbers satisfying the equation this. Points Z1, Z2 and 1 over Z1 and 1 over Z2 are the vertices of convex quadrilateral Q in the complex plane. When the area of Q obtains its maximum value, C is the closest to which of the following? Okay, let's analyze. Z1, Z2 is what? Z1, Z2 are roots of this quadratic equation. So If we use quadratic formula, it will be negative b, which will be c plus minus the square root of negative c squared minus 4 times 1 ac times 10 all over 2a, which is 2 times 1. And it will be c plus minus square root of c squared minus 40 over 2. It shouldn't be real. Why? Because if it is real, then z1, z2 are real numbers, 1 over z1, 1 over z2 are real numbers, and then the area will be 0, but it says maximum value, the area of Q. So, we can consider it is not a real number. If it is not a real number, it means what? Inside the square root, we should have a negative number. So, c squared minus 40 should be less than 0. And we can say it is c over 2 plus minus I times 40 minus c squared all over 2. Okay, so let's draw them. It will be what? Now let me tell you, if I want to find the length of z1, z2, you will see they are equal. Why? Because, first of all, without loss of geometry, suppose c is here, c over 2 positive. We can also consider when it is negative what happens. So if it is positive, then we can say, let me show with other color. This part, it is z1, z2. Maybe you ask why they are symmetric with respect to x-axis. I will explain. It is imaginary part, it is real part. And c over 2 is real part, but one of them. 40 minus c squared over 2. So if I use the dotted line, this one, it will be root 40 minus c squared over 2. And this part will be negative root 40 minus c squared all over 2. So we have these two things. Now, the length is what? You use Pythagorean theorem. C over 2 squared plus this over 2 squared. It will be c squared over 4 plus 40 minus c squared over 4. This will be cancelled with this because the denominators are 4. 40 over 4 is 10. So the length here is 10. So we can call this one z1, z2. We found the length is what? Now we want to find 1 over z1 is what? 1 over z1, 1 over z2. So, it is what? Sorry. It is z1 squared, z2 squared by Pythagorean theorem. So, the length of z1 equal length of z2 equal to root 10. Now, let's calculate 1 over z1. Suppose it is theta. It is negative theta. And without loss of generality, suppose z1 is root 10 in polar form. EI theta z to root 10 e negative I theta. Okay, 1 over z1 is 1 over root 10 e I theta, which will be 1 over root 10 e I negative theta. So 1 over z1 is here, and you can easily see that the length of this is 1 over root 10. So 1 over root 10 is less, so it will be 1 over z1. And similarly, with the length here is 1 over root 10. And the length of all is root 10. So if we calculate z2, 1 over z2 similarly will be 1 over root 10 e negative I theta. because of this. It will be 1 over root 10 times EI theta. So the angle is theta and the length is 1 over root 10. This part equal to this part. It is 1 over, it was 1 over Z1. This part is 1 over Z2. Now, let's calculate the area here. It says find the maximum area of the polygon that's quadrilateral that is created by Z1, Z2, 1 over Z1, 1 over Z2. This area is area of the whole triangle minus the area of this triangle. So the whole triangle, the length of height is C over 2 times this part, which will be 2 times this. 2 times 40 minus C squared over 2 and all over 2 minus the area of this part. The area of this part, we can say this is similar to this one. So we can do something. We can say if we call the whole things here, for example, we call it S, so it will be negative. So this part is 1 over root 10, 1 over root 10 over root 10, the length. The ratio of the two similar triangles is this. And because we want to find area, squared times S. So the answer here for finding area is S times 1 minus 1 over root 10 over root 10 is 1 over 10. It's 1 over 100. So it will be S over 100. So let's simplify 2 will be cancelled. 2 times 2 will be 4. Here it is. We factor from S. It will be 1 over 100. It will be C over 4 for S times 40 minus C squared. It will be this times 1 minus 100. And if we calculate, it will be C times 40 minus C squared times what over 400? 100 minus 1, 99. And now the problem wants what? The problem says what is the maximum value of the area and then find C. Because we want to find maximum area, so we should find maximum of this part. Because 99 over 400 is constant. If we want to find that, we should we should differentiate. So C times 40 minus C squared prime is C prime, which is 1 times 40 minus C squared, plus C times differentiate from this part, which will be 1 over 2 times 40 minus C squared to the power of negative over 2, and then times negative 2C. We should consider it is equal to 0. So if we simplify, it will be 40 minus C squared. These two will be cancelled. And we can take it to right hand side. It will be C times C squared. The negative will be plus over, because it is negative 1 over 2, it will be over the square root of 40 minus C squared. And if we multiply, we can also prove it with other ways. But one way is this. So I will tell you how you can prove with other ways. So let's solve solution number 1. Let me write here. So C squared equal to, if we cross multiply 40 minus C squared, so 2C squared is 40, so C squared equal to 20, so C is plus minus root 20. Without loss of geometry, we consider root 20. Now, let me tell you something. We said C squared minus 40 is less than 0, so 40 minus C squared is positive. I want to tell you solution number 2, how you find C. We know by AMGM, C times 40 minus C squared is less than or equal C squared. plus, because 40 minus c squared is positive, we can say 40 minus c squared over 2. And it is equal to 40 over 2, they will be cancelled, will be 20. And the equality happens when c equal to 40 minus c squared. If we raise to the power of 2, it will be c squared equal to 40 minus c squared. Then we calculate 2c squared equal to 40. Then if you divide by 2c squared equal to 20, then c is plus minus root 20. Again. Now, c root 20 is okay. It says closest to which of the following? So, let me tell you, root 20 is between 5 and 4. So we want to see it is nearer to 4.5 or 5. I told you before exam in my videos, I release how to find the square root. Let's consider square root of 20 with one decimal place. So I place 2 zeros for one decimal place. For each decimal place, you should place 2 zeros. From right, I consider this 4 times 4, 16. Then it is 4, then you have 2 zeros, 4 times 2, 8. You want to say you should place what here? If you place 4, 4 times 4, 16, we have 1, 4 times 8, 32, 33. So it will be 4.4 something. So 4.4 is nearer to 4.5. So the answer is A. If you want to learn how to work with complex numbers, the rules, the graph is so much important. To draw the graph. If you want to learn these things, important things that are useful in AMC exam and also other math exams, feel free to send message to my WhatsApp number in the description and comments, because there are some important formulas in complex numbers, how to draw a graph in different exams. We can work on AMC 12A 2022 problem number 23. Let Hn and Kn be the unique, relatively prime, positive integers such that 1 over 1 plus 1 over 2 plus 1 over 3 to 1 over n equal to Hn over Kn. Let Ln denote the least common multiple of the numbers 1 to n for how many integers n from 1 to 22 Kn is less than Ln. So, when you see these types of problems exactly before the exam, I release a video for preparation. You could solve hard problems of this exam with only that idea. Considering a small example and then generalize that. 23 and 25, you can solve both of them with that. In 25, you should use some geometric formulas that geometric formulas I told exactly the day before exam in the video preparation for AMC 1012. So let's work. I consider a small example, n1. 1 over 1 is 1 over 1, L1 is Kn. And it says we want that Kn be less than least common multiple of 1 to n. So it is not good. N2, 1 over 1 plus 1 over 2 is 3 over 2, which 2 equal to LCM of 1, 2. It is bad. Let's check N3. 1. Maybe when you check some small example, you think the answer is 0. But let's check some more. It will be 6. 6 plus 3 plus 2, which will be 11 over 6. N3 is this, n equal to 4. 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. Now, if we use LCM, it will be 4 times 3, 12. It will be 12 plus 6 plus 4 plus 3, which will be 7, 13, 25 over 12. It doesn't work. N equal to 4, and then n equal to 5. It will be 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5. Because we've calculated 1 to 1 over 4, it is 25 over 12. We don't need to calculate all of them. With 5, it will be 60. With 5, 25, 1 to 5 plus 12 equal to 137 over 60. And LCM of 1 to 5 is 6. So again, here it's not good, it's not good. Now it's the turn to find one good number, N6. I want to show you why 6 is good. 1 over 3, 1 over 4, plus 1 over 5, plus 1 over 6. So 1 to 1 over 5 is 137 over 60, plus 1 over 6. And now you will see, oh, it is 60, and then 137 times, no, we don't need, 137 plus 10, which will be 147 over 60. Now, let's see, can we simplify? both numerator and denominator are multiple of 3. It will be 4, 49. Let's check. 12, 27, 49. Yes. And 60 over 3 is 20. Oh, so LCM of 1 to 6 is 60. But here is 20, so 6 is the first good number. Let's analyze that why 6 is good. So when we consider 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6. The LCM is what is 60. Why? Because it is 2 squared times 3 times 5. And it will be 60. So if we want to reach a smaller denominator means we can, then LCM means we can simplify, like here. This part that we will simplify, divided both numerator and denominator by 3. So let's check. Let's check, can we divide by 2? If we check, we will see the numerator for first one, let me tell you, first, second, third. First one is, let me write, 2 squared times 3 times 5. Second one is 2 to the 1 times 3 times 5. Next one for 3 is 2 squared times 5. For 4, it will be 3 times 5. For 5, it's 2 squared times 3. For 6, it will be 2 times 3 times 5. Now, if you want to simplify with 2, we can see, because 4 has the maximum power, only 4 is odd. And other terms, all of them are even. Even. So, because all of them are even and one of them is odd, it is always odd. For also other numbers, you can see always the numerator is odd because only the maximum power of 2 is important. That one is odd, the other one is even. So you can simplify with 2. If you want to simplify with 3, we know, for example, this is multiple of 3, 3q1, 3q2. It is 3q3, 3q4. Oh, sorry. The last one is 2 times 5. Because it is 6. So it is not multiple of 3. We have 2 terms that are not. If you have only one term that is multiple of, for example, 3, then the whole thing won't be multiple of 3. But because we have 2 terms, like what? 3 and 6. Then if you consider all of them are multiple of 3, and we want to see all these two numerator multiple of 3 or not. We call this one LCM, LN. And we can say here, and here is 6. We say for this one, it will be ln over 3. For this one, it will be ln over what? Over 6. And if we add up ln over 3 plus ln over 6, it will be what? ln 6, 2ln plus ln, which will be 3ln over 6, which will be 2ln over 2. And we know ln is multiple of 3, so the sum of them will be multiple of 3. Now you understand, for n6 it is okay, for n7 also okay, for 8 also okay, for 9 we don't know. Why for 6, 7, 8 are okay? Because both numerator and denominator are multiple of 3. Because all terms are multiple of 3 except this term, 3 and 6. The numerator of them, if we consider ln, it is not important. N is what? 6, 7, or 8. Their sum is multiple of 3 and numerator will be multiple of 3. If you want to use same thing for 5, you will see it won't be satisfied. For example, ln of 5 plus ln of 10, you will see it will be 10 and 2 plus 1, 3 ln. It won't be multiple of 5. We want to use same thing. If you use, for example, ln of 5, ln of 10 plus ln of 15, you will see again, if you consider that, 15 times this will be what? 2 times 30. So 6 plus 3, 9 plus 2, 11 ln. Again, it is not multiple of 5. And up to 20, because we work up to 22 if we consider also ln of 5, 10. Let me tell you something. Because for 3, 6 we said, when we have 9, again, when we reach 18, for 9 and 18, similarly we have this. So 6 is good, 17 good, 8 is good, again, 18 is good, 19 is good, 20 is good, 21, 22 is good. Up to 26 is good, but the problem says only consider up to 22. Now, because let me tell you, for example, 5 after 18 is good, because you say ln over 9, then all things are multiple of 3 except 9 and 18. ln of 9 plus ln of 18 will be what? Will be 18. 2 plus is 3 ln of 18, which will be ln over 6. And ln is multiple of 9, so the whole part is multiple of 3, so numerator and denominator will be multiple of 3. And we don't need to check ln 20 to ln 20, because we know 20 because of 3 is good. For 5, you will understand it is not good. For 7 also you can check it is not good, because ln 7 plus 2ln, if we want to check 14, 2ln 7, it will be 14. Let me check ln of over 7 plus ln over 14. It will be 3 ln over 14, which is not multiple of 7. For 11, the first number, 22, we know it is okay because of 3. So 1, 2, 3 good numbers, 4, 5, 6, 7, 8. So we have 8 good numbers. This problem was hard for AMC. The difficulty is related more to AME or other exams, a little also harder than some problems of AME. But look, by considering a small example, we found the idea. Also, we can prove for general M. We can work on this exactly. We can generalize this idea. If you want to learn generalization here, and also other ideas that are useful in your next exams, like this exam that I release a video and I explain working on a small example, special cases. If you want to learn these ideas, feel free to send message to my WhatsApp number in the description and comments. AMC 12A Pro 2022 problem number 24. It says how many strings of length 5 formed from the digits 0, 1, 2, 3, 4 are there such that for each j belongs to 1, 2, 3, 4, at least j of the digits are less than j. For example, this satisfies because 1 digit less than 1, 0. At least 2 digits less than 2, 0, 1. At least 3 digits less than 3, we have also 4 digits. At least 4 digits less than 4, 0, 2, 2, 1. But this one is bad because it doesn't have 2 digits less than 2, because we have only 1 digit, 0, less than 2. And we should calculate some of them, the number of them. So for solving this, we should work on considering cases. And exactly before the exam, I released a video preparation for AMC 1012. I solved example from this, from past years of AMC. I told that this idea is useful in HMMT, Harvard, MIT Math Tournament, and other exams. Some problems that don't have any idea, spatial formula, you should consider one property. It is not important. For example, someone says 0, 4, 2, 3. Consider one property and consider different cases of that property. Then if one case was hard, again consider another property. So let's see here it's what. Consider n of 0 is number of ones. So n of I is number of I in string. So it says for J1, the number of digits less than J means 0, we have only. Less than 1 is at least J1. If J is 2, number of digits less than 2 means 0 and 1, n of 0 plus n of 1 is at least 2. If J is 3, n0 plus n1 plus n2 is greater than equal 3. And last part, j equal to 4, we have 4 conditions. n0 plus n1, digits less than j means less than 4. To 3, 0 to 3 is at least j, which is always 4. So now I want to consider the cases of n0. So n0 can be 4, 3, 2, 1, because n0 is at least 1. So if it is 4, it is 3, let's check 2, 1. For 4, we have 4 zeros. Sorry. The problem says the length of a string is what? Is 5. Okay, so we should start from 5. So if you have 5 zeros, then we have one string and satisfy all 4 conditions. If you have 4 zeros, also it satisfies all 4 conditions, but 1 digit is left. So you should say 5 choose 4 for zeros times. The digit that is left can be 1, 2, 3, or 4. Because the digits are 0 to 4. So it will be 4, it will be 20. Now, this case, we have 3 zeros. So the first, second, and third condition will be satisfied. We should pay attention to fourth condition. So you say we have 5 choose 3, 4 zeros, and we have 2 digits that are left. So these 2 digits can be 1 to 4. You say 4 squared, but the bad case is what? The only bad case is n30, and this one we know 3. These parts should be 0, all of them, that it doesn't satisfy. So means that we have only 4. The 2 others are 4. So minus 4, 4. Both of them should be 4, unique, one case. So 5 to 3 is 10. 16 minus 1 is 15. Of that, 0 is 5 choose 1 times. Now we focus on n of, we have 4 ones, 3 ones, 2 1, 1 1. And because n of 0 is 1, for second condition, n of 1 should be at least 1. So here, let me copy the conditions that here we have. So we have these 4 conditions. And we want to focus on them. The first one is satisfied because n0 is 1. n1 is at least 1. The second condition is satisfied. So let's consider the other cases. So in first case, we have 1 0 and the other 4 places are 1. All of them 1. So we have one case. So times 1 here. So 5 times 1, which is 5. Now, here we have 3 ones. Now, we can say, because we have 3 ones, this and this will be satisfied, because n1 will be 3 and 0 is 1. So it will be 4 choose 3 for ones. The other one can be 2, 3, and 4, which have 3 cases. So 5 times 4, 20 times 3, 60. Now, let's check when we have 2 ones. We have 2 ones. So first we say 4 choose 2. When we have 2 ones, it will be satisfied. Third one, because n0 is also 1. Now, we have 2 places that are empty. I say all the cases, you fill them with 2, 3, 4, 3 squared minus the cases that j equal to 4 is not satisfied. It means what? We know it is 1 and 1 is 2, so it should be 0, it should be 0. So we can only have 4, so the other places should be filled by 4 1 cases. 9 minus 1 is 8. 8 times 6, 48. 5 times 48, which will be 240. Now, let's check the last case that we have 1 1. So, we have 1 1. Okay, it is 4 choose 1 times. So this condition is satisfied. Let's consider the case that J3 is not satisfied. Here J4 was not satisfied. J3 is not satisfied means what? It is 1. It is 1, so N2 should be 0. So when N2 is 0, we can fill the other parts with only 3 and 4. So it will be 2 cubed minus the case that J3 is satisfied, but J4 is not satisfied. Because J4 is not satisfied, we can say that J3 is satisfied, it should be 3 and it should be 0. So because we know it is 1, it is 1 and 2 should be also 1 because J3 satisfied. So let's see what happens. We have 2, n of 2 is 1, so you select 3, choose 1 for 2 times, we don't have 3 and the others will be 4. So it will be 1. So, sorry, they were bad cases. I should subtract them from all cases. So let me take them here. it will be 3 cubed minus these things. Okay, so if I calculate, it will be 5 times 4 times 27 minus 8 minus 3. 27 minus 11, which is 16. 5 times 16, 80. 4 times 80, it will be 320. Okay, now let's add up the numbers. 1 plus 20, 21, 171. 171 up to here, 671. 671 plus 1, 676. Then this one will be 6, 13, 736 up to here is 6, 437, 976 up to here will be 6, 7 plus 2, 9, 9 plus 3, 12. The answer is 1296. Okay, it was this. Look, there are lots of problems like this in HMMT, other exams. If you want to work on these types of problems, you consider different cases. As I said before, feel free to send message to my WhatsApp number in the description and comments. AMC 12A 2022, problem number 25. Finally, last problem. A circle with integer radius r is centered at r. Distinct line segments of length ci connect points 0ai to bi0 for I between 1 and 14 and are tangent to the circle where ai, bi, and ci are all positive integers. And C1 less than or equal C2, 2 less than or equal C14. What is the ratio? C14 to C1 for the least possible value of R. Okay, so let's consider the figure first. Okay, if we consider the center is RR, so the points that the lines CI, length CI that are tangent can be here. The circle be out inside, or it can be something like this. Okay, so let's consider we know it says 0ai, it will be ai. It will be, let's consider first it is a, for example, it is b, and the length here is c. Okay, and also this part, it is a. It is b, and the length here is c. I want to write all things that are useful. So, before the exam, I released exactly the day. It was preparation for AMC 1012. I set some formulas, one of them useful here, some of them. If you want to learn all of them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, the formula here for R is area of triangle ABC. For example, let me call this triangle ABC. Triangle ABC over semi-meter. And it will be what here? Because we have right angle triangle, the length here is A times B, AB over 2. And semi-meter will be A plus B plus C. It is so much famous formula you should memorize. And the proof is easy. In one line we can prove. If you want to know the proof of these formulas, as I said before, feel free to send message to my WhatsApp number in the description and comments. So it will be AB over A plus B plus C. It is one formula. And here, we can call this one X. If here, for example, we have A here, B here, C here. We call this X radius of A. And the formula, and here it is R, the formula is area ABC over S minus, here the length is, because the length here is C, let me consider something. Let me consider the vertices in a different form to be related, because small c is better to be an opposite of this. It is B, so we call this one B, we call this one A, because this side is this. And then it will be A, it will be B, it will be C. So here, if I want to say, I say RC, because it's X radius of C. And let's call this one RC. RA is area over S minus A, RC is area over S minus C, because this length is C. And it will be AB over 2. This part will be AB minus C over 2. If you multiply both numerator and denominator by 2, it will be a plus b minus. And other formulas that we have is useful for both of them. We know in both of them c equal to c squared equal to a squared plus b squared. Another thing that is useful. The length here is r. It is r. And this length is a, so it will be a minus r. And we know it is equal to this. It is a minus r. This length is r. And we can conclude because the whole thing is b. It is b minus r. It is equal to this, so it is b minus r. So c equal to here b minus r plus a minus r, so it is equal to a plus b minus 2r. And here, again, we can say it is a, the whole thing is r. So this length is r minus a. This length equal this length, so it is also r minus a, this length. And again, this part is r minus b, and because this length is equal to this length, so it is also r minus b. So here we can say r minus a plus r minus b equal to c, which is 2r minus a minus b equal to c. Now, let's combine these things together. The first equation I can conclude RA plus let's consider from 1. If I cross multiply RA plus RB plus RC equal to AB, and if I consider this one 2, if I apply 2 here, instead of C, I replace C with A plus B minus 2R. So it will be RA plus RB plus R times A plus B minus 2R equal to AB. Now, RA plus RA equal to 2RA, RB plus RB equal to 2RB minus 2R squared equal to AB. So, here I can say it is this. Let's also analyze this part. Let's call this one 3. If we cross multiply 3, it will be RA plus RB minus RC equal to AB. And then we can replace C here with 4. So if I use 4 here, it will be RA plus RB minus RC is 2R minus A minus B equal to AB. And here I can say RA plus RA is 2RA. RB plus negative R negative B will be RB. It will be 2RB minus 2R squared equal to AB. So now we will see it's not easy to calculate. The first thing I want to do is to consider if R equal to, for example, 1. So let's see what we have. It will be 2A, the first one, plus 2B minus 2 equal to AB. And this part will be 2A plus 2B minus 2 is AB. So we will see the equations are same. Okay? So for a small A and B that are less than, for example, R in general, we should use this. AB greater than R, we should use this. Okay, so let's solve this one. And before the exam, I released many videos, and I said if we want to solve this, we should use SFFT. We call it Simon's favorite factoring trick. We take all things AB to one side, AB minus 2A minus 2B equal to negative 2. Then I say A minus 2, B minus 2 will create AB minus 2A minus 2B, but we have 4 more. So we should add also left hand side by 4, and we should add 4 to left hand side, it will be 2. So A minus 2 times B minus 2 is 2, so we have 1, 2, 2, 1, negative 1, negative 2 is not possible because then B will be 0. So in this case we don't need to consider. And then A will be 3, B will be 4. And this one, vice versa. A, 4, B, 3. And if you check, let's check. R1, A3, B4, and C will be 5. So we will see we have only this case. A, for example, equal to 4, B equal to 3, and C equal to 5. And if you use this formula, AB will be 12, A plus B plus C will be 12, and all things will be correct. But here, we found only 2 answers for A and B. And, okay, so 4, 3, 3, 4, and it will be 4, 3 here, 3, 4. We found 2 answers, but the problem says how many answers? We find 14, so 2 is too small. So if you check other numbers, let's check, and you understand for each of them it will be what? Now, I say if I want to use SFFT here, first thing, by considering a small example, that I said a small example is useful, and we've solved more than one problem with a small example in this AMC, and I told you exactly the day before exam, pay attention to that. We found that SFFT is useful, Simon's favorite factoring trick. So 2RA, let's consider 2RB minus 2R squared equal to AB. I take this and this to right hand side. It will be negative 2R squared equal to AB minus 2RA minus 2RB. It will be A minus 2R, B minus 2R equal to, then we have 4R squared. We should add 4R squared here. It will be 2R squared. So for R1 we've checked. Let's check for R2 to see what we can reach. Then we have A minus 4 times B minus 4. AB should be at least 1 because they are positive and they should be integer. It will be 2 times 4, 8. So because A minus 4 is A is at least 1, it will be at least negative 3. Also, it will be at least negative 3. The product is 8, so it will be 1, 8. And you can also consider 8, 1. I don't write it and then multiply by 2. 2, 4. I don't write 4, 2. Negative 1, negative 8 is not possible because it should be at least negative 3. Negative 2, negative 4 also is not possible because it should be at least negative 3. So we have only these two cases, and if you multiply by 2, we have 4 answers. So R2 is not good. If you check R3, A minus 2R 6 times B minus 6 is 2 times 980. Both of them should be at least negative 5. So I check 118, 2, 9, 3, 6, and we multiply these answers by 2. If we want to consider negative of any, these things are not useful, so we found 6 answers here. It's not useful, we want 14. Because look, 3 is prime. Let's check 4 are equal to 4. A minus 8, B minus 8 should be equal to 2 times 4 squared, 32. Because A is at least 1, it is at least negative 7. Also B minus 8 is at least negative 7. It can be 132, 216, 4, 8, and you multiply by 2. If you want to consider negative of them, they are not possible. So again, we have 6 answers. So here, if you check 5, it's obvious that for 5, because it is prime, the number of answers is less. Then for 6, we have more answers. A minus 10, B minus 10. It will be 2 times 25, 50. And it is at least negative 11. It is negative 9, sorry. Because A is at least 1, negative 1. A is at least 1, so 1 minus 10, negative 9, negative 9. Now, if we want to create 50, we have 150, 225, 5, 10. We have this, and we multiply by 2, 6. If we consider negative of them are not okay, so 6 answers. It won't reach 14. Now, 6 is good because it has 2 primes. Let's check. A minus 12 minus 2R. B minus 12, it will be what? 2 times 6 squared, 72. A is at least 1, it will be negative 11, at least negative 11. And then, if you consider the first term times this one, it can be 172, 236, 324, 418, 6 times 12, 8 times 9, and you multiply by 2 for negative numbers. You can also consider negative 8, negative 9. Yeah, so 1, 2, 3, 4, 5, 6, 7. 7 times 2, 14 answers. So here we understand our 6 is good, but we should find C1, C14, and C is what. So first, I should find AB. AB is, you should add 12 to each of them. 13, 12, 84. It will be 14, the next one. And then 12, 48. This one by 12, 15, 36. This one by 12, 16, 30. If we add 12 here, 18, 24. If we add 12 here, 20, 21. If we add 12 here, it will be 4 and 3. Okay. So we have 7 cases, and it says CIs can be equal. So if you want to find, it says C1 less than or equal to C14. And one thing maybe you ask, that C should be integer because it is square root of A squared plus B squared. And you can see C of all of them are integer numbers. For example, the first one, 4 squared plus 3 squared, 25. It will be 5. 20 squared is 400. 21 squared is 441. Some of them is 8. It will be 841. And it will be 29. But the problem says what? The problem says find the C14 over C1 for the minimum R. And this R is minimum. R equal to 6. C14, the greatest one over the smallest one. Obviously, we can say C1 is 5, the smallest one. And the greatest one is this one, because it is 84 is greater than 6,000. But if you consider all of the others, and they will be less than this case. So you need to calculate this one for exam, but at home you can calculate C of all of them, all other cases, and see all of them are integers. If you calculate this, it will be 85. And it will be 85, so C14 over C1, which will be 85 over 5, which will be 17. And the answer, let's check. The answer is, what is E? Okay, but let me tell you other C's are what. At first, try also calculate them by yourself. Let me tell you something to calculate easily. For example, when you want to calculate 1536, you say C squared is 15 squared plus 36 squared. You factor from 3 squared. So it will be 3 squared times 5 squared times plus 12 squared. So you say 5 squared, 25 plus 12 squared, 144 is 169. So square root of that is 13 times 3, 39. So you calculate 39. For example, this one, you say, you factor from 2, it will be 2 squared like this one, C squared. 7 squared plus 24 squared. 7 squared is 49. 24 squared is 576. If you add these two numbers, 6 plus 9, 15, we have 1, 1 plus 4, 5 plus 7, 12, 6 to 5. And if you consider, it will be 25 times 2, square root 50. And the next one, for example, here, we factor from 2, it will be C squared is 2 squared times 8 squared plus 15 squared. It's 225 plus 64. 225 plus 64 is 289. If you consider square root, it will be 17 times 2, 34. This one, this one, this, and for this one, you factor from 6. C squared will be 6 squared, 3 squared plus 4 squared. Here it will be 5 squared, so C is 5 times 6, 30. Okay, so we have 2 5s if you want to calculate. Then we have 229. Why 229? Because 2021 and 2120, you can switch A and B. And up to last one, 85, 85. And this, you can also draw the diagram for each case and see which of them the line. Here we have type 1. In which of them we have type 2 and this. Okay, so if you want to learn other geometric formulas, feel free to send message to my WhatsApp number in description.